Welcome to our channel. In this session, we are moving with the program same tree. First, read the question. Given the roots of two binary trees, P and Q means they are given two trees. The root of the first tree is P and the root of the second tree is Q. Write a function to check if they are the same or not. Means our aim is they given two trees. You need to check whether the two trees are same or not. Based on what condition we are saying the two trees are same or not? So they given the condition also. Two binary trees are considered the same if they are structurally identical. Means the structure of two trees are same and at the same time the node have same value. See the example. One is the root, one is the root. One has left child, one has right child. Left child value is 2, right child value is 3. Similarly, here left child value 2, right child 3. The structure is same. At the same time, the values are also same. Now, both the trees are equal. That is same tree. Coming to the second one. Here, even though the values 1 and 2 are same, but observe the thing carefully. Here, one has the left subtree, but in the second tree, one has the right subtree. So, the two structures are not same. So, the two trees are not identical. The output is false. In example 3, even the structure is same, but the values are different. For one left side is 2. In the second tree, one left side is 1. You got it? That means here based on two things. One is the structure of the trees and at the same time the value of the tree. Based on the two conditions, you need to check whether the trees are same or not. How do you check? First, write down the base condition. For any program, what is the base condition? Suppose if there is no tree, that means what the condition I written? If not P and not Q. So why I used the term P and Q? In the question only they given. P is the root of the first tree. Q is the root of the second tree. If not P and not Q means P and Q are not existed. Remember, if both the trees are not existed, then what is the output? False or true? Obviously, the output is true. Why? Both the trees are null only. Both are null. Obviously, both are same structure and same value. The value is null. That is the reason I written true. Now, exactly, I am checking one more condition, not P or not Q. That means if either P or Q, one is not available, and obviously the structure is different, the return false. So anyway, these are the base condition. Whether the Q is present, that is whether the tree is present or not. Now, understand the question carefully. You need to check the values also at the same time. For example, assume this is my first tree and this is my second tree. Initially, this is P, this is Q. Now observe what I am doing. I am checking this value with this value. In the program, they given, move to the program. Observe, in the program only they given P self dot val is the value and left which is used to store the left side, right which is for right side. Okay, exactly. First, what I am doing, I am comparing P dot val is compared with Q dot val. If both are equal or not equal, at any point, if it is not equal, then what I written? I written false. Completed. Once you use the written statement means the program completed successfully. Suppose if this is not the case, then what I written? If the if condition false in the sense in the else, even you no need to write. 1 and 1 both are equal, then you need to check this left, that is p dot left is compared with q dot left. The same procedure is repeated. For that, what I am doing? I am using recursion. What is the tree name? Is same tree. The function name is same tree of p dot left comma q dot left. Here, once this happened, what happened? P dot left, now p points to this one, q dot left, q points to this one. Again, first to this condition, followed by this condition, followed by this condition. Again, 2 and 2 both are not equal, condition for this happened. Exactly. At the same time, what you need to check? Once the left completed, you need to check the right also. P dot right comma q dot right. At any point, if the values are not equal, I am returning false. Now observe how do I write the program. The same logic. First I am writing if not P and not Q. That means P is not available, Q is not available. What I return? I return true. Means both the trees are equal. Suppose the if condition fail. Next I am checking one more condition. So if not P or not Q, that is either one. In that case, what I return? False. What I return? False. Okay. So this is just for checking P and Q structure. Now you need to check the value. If P dot VAL is not equal to Q dot VAL, P dot VAL is not equal to Q dot VAL. At any point, if the values are not equal, now what you need to return? Return false. Suppose if all the if conditions are fail, means here not P not Q means null. This condition fail, this condition fail, and this condition fail means at least one element is available. At least n one element is available. If no element is available, not P returns true, not Q returns true. So if at least one element is available, what I am doing? Call the recursion. Same tree of P dot left comma Q dot right. Now you got it. In the next iteration, what is the left side? Assume 2. Now 2 becomes P value. This 1, whatever it is. So here this one becomes not right, sorry, left. This one becomes Q value. Both the sides I am moving to the left side, and at the same time you need to check right also. Is same tree of P dot right, comma Q dot right. This is. So I am returning this one at any one point. This value is returned. At one point, this value is written or this value is written. Now execute, run this program. Is going to be executed. Got it? You need to verify the structure at the same time the value. Anyway, we are getting some error. Check the error. What is the error? Is same tree. So return self dot is same tree of p dot left comma q dot left. This is right. RETURN and self dot is same tree of p dot right comma, by mistake I given full stop, comma, run. Okay. This is for left checking and the second one is right checking, and at the same time you need to compare both. If both are okay, then only it is possible to check the trees are same or different. Okay. Now see, accepted. Now I will submit the answer. The test cases are accepted. Once I submitted, if everything is good, now observe, submitted and accepted, and it beats 100%. That means your program is efficiently all right. Now you got the concept. This is the concept of to check whether two trees are same or not. That is the end of this program. Thank you.